I have a section of 24 millimeter standard wall tubing. It's about 7.5 inches long, and it's in the chuck. Inside of it, there is a flared glass tube, approximately 8 millimeters. It's artistic glass, so kind of standard wall. What I'm going to do is I'm going to construct a bubbler on the lathe, and the bubbler consists of a side seal, a straight seal, a ring seal, and then you close the bottom as a test tube. So what I want to do for this demonstration is I'm going to start by making the side seal. Then I'm going to make the straight seal, but the straight seal will actually be a cold seal. Then my plan is to bridge the two, clean up the straight seal, remove the bridge, and then come in here and do the ring seal. Where this will get tricky is as I'm doing the ring seal, this will be rotating, so I'm going to have to stay over here and make sure I just literally don't bump into this as it's spinning around. And of course, once I make that ring seal, I have to make sure that as I work the glass, that I keep everything heated in a reasonable uniform way, and then allow it to cool down without putting too much stress in it and causing it to crack. And again, if I really, if I do have issues with this, the other way to protect the ring seal would be to put a Bunsen burner, like right about here, and then just have that soft flame just keep everything hot. So I'm going to try and do this without the Bunsen burner, but if it does become a problem where the ring seal is cracking, then I'll come back and do it that way. And I'll have my blow hose in my mouth once I get started, because I'll need to blow into this. The first thing I'm going to do for the side seal is just warm it up. Okay. Alright. Yeah. If I heat the lip, I can open this hole up. And get a little bit even before I use my tungsten pick. Okay, so I have a good stick. So now what I need to do is clean up this seal. I'm changing the RPMs. Okay. Maybe one little adjustment here. I'm just going to warm this area up. Okay, so now, warm this up. Actually, get that in position. I forgot to mention, I could actually make a side seal instead of a straight seal for this connection, but I'm going to go with the straight seal. This is where the gas will enter the bubbler. There are a few places I could clean up, but overall, I'm gonna say that'll be fine. So now I need to remove the bridge. Come in here, heat very strongly, do the same. Now burn that off. In this case, I'm going to take this opportunity to shorten both these tubes. Which was the plan from the beginning. They don't need to be this long to function for a bubbler. I will come back later and open that up when the bubbler is nearing completion. Okay, so 2 of my 3 seals are done. Now the ring seal, which is again the tricky one. I'm not super happy with my straight seal, but I'll take it if it stays where it needs to. Now again, the trickiest part is heating, but not getting in the way of my side seal. I should say not getting smacked by my side seal. In fact, I really don't need to go that fast now that I think about it. Okay. Right now I'm just basically warming up that entire area because again, glass is an insulator, so it takes some time for the inner glass to heat up. And so now increasing, I have my paddle. So as this starts to collapse, I can bring that back on center. I want to be careful not to heat up too much glass. That's how it's getting a little out of control. Right now I have a straight seal, a ring seal, but I want to work it in a little bit more just to be on the safe side. So I'm alternating between heating it, letting it condense, puffing it back out, and repeating. And right now, it looks like we have a ring seal. Again, it's all the way around the circumference. It looks reasonably uniform. This stage, I'm going to use this annealing flame. The ring seal, obviously being right next to the side seal, again, that's a large area of stress, potential stress. The annealing oven is actually on, so as soon as I see a little bit of soot starting to build up on this, I'll take it and put it directly into the annealing oven, which I can do that because I'll be able to take this out wearing gloves. But yeah, this flame that I'm using, again, is hopefully doing its job, protecting my ring seal. My camera's battery died as I was finishing up the bubbler. So we have our side seal, our ring seal, and our straight seal. I'm going to take this over to the polariscope in a second. To finish the bubbler, first I'm going to pop a hole here because these are closed. Then I'll switch my blow hose over here. I'll close this, and then I will pop a hole there, and we're done. I'll probably anneal it a second time, but really the heavy lifting is, without a doubt, the ring seal is the trickiest. Then actually the straight seal can be a little bit difficult as well, and then the side seal. So. But anyway, I'm going to take this and put it on the polariscope. This has been through the annealing oven, so it should not have any stress. So here's the glass under the polariscope, and it looks good. I think there's some weird artifacting because you got the pink glass on the inside, but I don't see any stress, which would typically be like some blue lines over here or anything like that. So that's good. And as I mentioned, this has been through the annealing oven. My biggest concern in this construction was that the ring seal was going to be the source of a crack if it cools down too rapidly. What I did was, as I was finishing up, I put soot on here. I basically turned off the oxygen and just had a sooty flame. And then when I turned that off, I went directly from the lathe right into the annealing oven, which was already preheated to 500 degrees Fahrenheit. And then it went through the normal annealing cycle. So now it's just a matter of finishing it off. Here is the bubbler right out of the annealing oven. I've opened up the side seal and the straight seal, so it's complete. We've got our ring seal, side seal, straight seal, and of course closed off at the end as a test tube. And what I'm going to do next is just fill it with some silicone oil and hook it up to a schlenk line to actually let it do what it's designed for. Alright, my bubbler is now hooked up to my schlenk line. So through here, argon will bubble through and out through the bubbler. So let me actually turn this on. And there you go. Okay. And for those of you who don't know what the function is, it's to help you regulate the flow of gas when you're doing experiments on the schlenk line. So, critiquing this, my straight seal's a little off center. I could have done a much better job on that. My side seal is okay. I could have worked that in a little bit better. The test tube, actually, the bottom, that actually looks pretty good. And most importantly, the ring seal actually looks very good. The ring seal is usually where you have the most stress, and that's usually where it's going to break. So I'm happy with that. And you can see, again, my bubbler is literally doing its job. So I am very, very happy with that. And again, on the lathe, I didn't mention this, but the 3 pieces of tubing that were attached to the main body, they were flared on the micro lathe. And then I have the video showing the attachment of our side seal, our straight seal, our ring seal. And I did the test tube by hand on a bench burner off camera, just because it didn't make sense to try and put it on the lathe based on its size and just the irregularity of it. So the lathe isn't for every single thing that you're going to do, but for certain actions, like making a ring seal, it's going to be much, much better than doing it by hand, especially if you're a beginner. So again, the lathe gives you a mechanical advantage, so you should take advantage of that if you can.